Welcome to part 2 of LipidMatch tutorial. This is Jeremy Comel. And in this tutorial we're going to be looking at the input files you'll need to run the LipidMatch code. And there's two types of input files you'll need. The first is your tandem MS data. And so this tandem MS data is going to be coming from your vendor formats and be converted to an open source format .ms2. And in order to do that, we'll use MSConvert. So MSConvert can be downloaded from ProteoWizard tools, and the link to download that is in the document manual that comes with LipidMatch. Now we'll click Browse. We'll go to our desktop and find our files. So in this case I have 4 files containing data-dependent data. Top 5, and I'll highlight those using Control-click, and then I'll click Open. Now we can convert those to a .ms2 format. So here's your output format. I'm going to select MS2. If we go to our filters, we'll start with peak picking. And we'll go to the second level, click Add, and we'll go to MS level, and we'll also do the second level. And so the reason we're doing the second level with peak picking is that it will reduce the file size and it will increase the speed at which LipidMatch works. Finally, we'll go to Threshold Peak Filter. Go to Most Intense, Absolute Intensity, and 0.0001, and we'll click Add. Now that you've checked all your parameters, which should look like this, and your output format, which should be MS2, you click Start. Now, while it's progressing, it will either say that it was completed, finished, or it will have failed. If it has failed, just rerun that sample in which it failed for, and it should work. Once it's finished outputting your files will appear in the same directory in this case, where you uploaded them. And the icons might look different. The second set of files you're going to need is going to be your feature table. So your feature table is the table which has your peak areas, maybe heights, any statistics like p-values, fold change. But most importantly, your peak table has to have a row ID, which is numeric for each feature, the mass to charge of that feature, and the retention time of that feature. So those are the 3 columns needed for LipidMatch, and any other data can be included. And it can be in any format, so the data can start in any row, there can be any additional columns, and the row ID and row mass to charge and retention time can be in any column, because LipidMatch will ask you for those columns and which row the data starts in before it processes the data. So, for example, this would be an output from MZmine. But you could also include one from MS-Dial. So again, it will work because we have our alignment ID, our retention time, and our mass to charge. So any other additional information, such as Ichnikis or smiles, can be included as well. So one more thing to note, as you see this says positive peak heights. You want to have a separate feature table for your positive mode data and your negative mode data if you have both polarities or just one or the other. Once you have those feature tables from MZmine, XCMS, there's a lot of open source as well as proprietary software you can use to get these type of feature tables, then you're ready to run LipidMatch. In the case that your lab doesn't have a setup to get feature tables, I'm going to show you how to use MZmine. So LipidMatch has included a batch file for MZmine, which can make your processing very rapid. So you want to start by opening up MZmine. So in this case, I'm going to use MZmine 2.2, and that's the one you'll need to use if you want to use my batch file. So you click Start, and it's going to open up MZmine. So now you want to import files that are .mz.xml. And so again, we're going to go to MSConvert, and we're going to upload the raw files that contain your full scan data. So let's remove the old files, browse. So here we have our negative full scan data and our positive full scan data. We open those. And again, we're going to use the same settings, but instead of the second level of MS, the MSMS spectra, we're going to look at the full scan data. And the output format we're going to save as MZXML. So let's start with our peak picking again, and the order does matter. And we're going to remove our old filters. So you want your first one in the order to be peak picking at the MS1 level. Then you set the MS1 level to 1. And you set your threshold peak filter. Then you click Start, and you have your MZXML files. The reason that we convert to MZXML, even though MZmine can now take in raw files, is due to the fact that you can use the vendor peak picking, which will make MZmine run a lot faster. Once you wait for those to finish, they should show up again in the same directory, and we're done with MSConvert now. And so we'll go back to MZmine, and we'll now import those files. And in MZmine, you want to run each polarity separately in this case. So I'm only going to open up the negative mode data. So now we have our negative mode data, and you can either set up your own method on how to deconvolute the features using MZmine and the MZmine manual, or you can use the batch mode file that I included. So you'd go to Project, Batch Mode, Load, and you'd go into the folder that came with LipidMatch. So in this case, LipidMatch Enhanced. This is the batch file. And this batch file, which you'll replace, is for resolution 35,000 or above, and peak widths between 0.1 and 1.5 minutes, so using UHPLC conditions. So once you have your batch file loaded, you press OK. But first, you have to highlight your files. So now it's running the batch mode. Now the great thing about MZmine is even using the batch mode that I included, you can check your features. So make sure that it picked out good chromatographic peaks. And so you can do that with the output. So it's going to output, and every output you can double click and open and visually see what's being done to the data. And so the final output is the most important, which is going to have your aligned peak lists that are gap filled. So you can look now at the peak shapes. You can look at the heights and the areas. And if it's yellow, that means it was gap filled. And if I want to look at one specifically, I can go to Show, XIC Dialog, Highlight, and look at the peaks. So here you can see the peak for 766, and you can see in colored where it took the peak area and the XIC for that mass. So you can check the peak quality. And there will always be peaks that are pulled out that aren't actually peaks, such as these odd peak shapes. That's just the name of the game, no matter what software you use. So now you want to export this aligned peak list as a CSV. So I'm going to click Peak List Methods. I'm going to go down to Export, Export to CSV file. You want to highlight the row ID, the row mass to charge, the row retention time, all identity elements, and you can either choose peak height or peak area. And if you want both, just save them separately. So click peak height, press OK, and then peak area, and press OK. And you'll also have to choose the file name. So browse to where you want to save it, and then type in a name here. So output negative example.csv. You can click select file now and click OK. So now it's saved, and you can double click, and here's what you'll get with your peak heights and your ID, row mass to charge, and row retention time. And so that concludes our tutorial for part 2, and I look forward to seeing you in part 3.